Hi everybody, this is Jim again, and I'm going to talk briefly about HEMI2, and then I'll do another video where we dive right into using it in blue spray. Important points: it uses Bezier curves to minimize overfitting. It allows automatic fitting, so you can either do manual adjustment or you can have it automatic or both. And it has a bunch of Monte Carlo features for validation and uncertainty analysis. So as I said in the previous presentation, the issue here with overfitting the data, and this is again Maxent in its default mode, will tend to overfit, and next week we'll talk about how to prevent Maxent from doing that. But when we look at the shape of these curves, it's really the shape of these curves, how species would respond to their environment, and especially most of my work was done with plants, which some would argue that plants have a simpler interaction with their environment than higher animals, and I would agree with that. We'll talk more about that a little bit later. But it's the idea that these curves should be relatively smooth. Modeling these with polynomials is complicated because polynomials are hard to control. And if we take a look at the environmental space, this is a three-dimensional histogram of temperature and precipitation for the entire United States. In other words, if you take the annual precipitation, which is millimeters of water on the bottom, so 3 meters max, and then on the other axis, temperatures in degrees C times 10 minimum, and that's minimum coldest month because again looking at plants. What you see is green where there are very few pixels in the US that have that value, and red where there are lots of them. So once again we see that the United States has lots of dry areas, and here we can see that also has lots of dry, colder areas. And then I found it fascinating that the US has this point attribute to it, this arrow shape, where we have a very small area that has the highest precipitation, and that's across a very narrow range of temperatures, these middle but higher temperatures. And so yeah, this interesting shape is actually a histogram of the US environmental space. And this also is interesting to me, these sweeping curves, and it took a while for us to understand what these were, and then we found out these are mountain ranges, and mountain tops are the coldest points. Okay, and they tend to have fairly consistent precipitation, but dropping as you go up in elevation. So these sweeping lines are mountains. I just found that to be cool. If we overlay tamarisk, again a desert species that I worked with, you can see that here's where tamarisk tends to be, where it's very low precipitation, but a pretty good range of temperatures represented. Now these charts aren't actually used by any current habitat suitability modeling package, but I thought they were interesting to allow us to be able to look at the environmental conditions. So these are different approaches. BioClim is one that's been out there for a while. I actually recommend looking at it because it just uses min and max boxes around rectangular boxes in the environmental space, and it actually does pretty well. None of the other approaches except for Maxent, which isn't listed here because we're going to talk about it soon, and hyper envelope modeling, or HEMI, my stuff, are really the ones being used now. But BioClim was very interesting and performed well with very little complexity in the models. So HEMI uses Bezier curves. These are similar to the spline curves that we saw, except they allow multiple X values for each Y value, and vice versa. They're curved in two-dimensional space. If you've used the curves in PowerPoint or Illustrator, the curve tools, you've used Bezier curves. That's the math at the top. You don't need to memorize that. And this is a single Bezier curve. You can see it's got points and then control points allow you to control the curvature. I modified these to represent any surface effectively, any shape, by tying them together and then using the slope instead of having control points. So controlling for the slope at each point instead of having separate control points, and this allowed them to be continuous and also made it much simpler for us to edit and handle the curves. didn't have to deal with the control points. A little more complicated. HEMI2 is also limited to one response curve for Predictor, which is similar to Maxent traditional regression. The predictors can be transformed. That's up to you. It only supports 10 predictors right now. I don't think it needs more than that. It also has what I think is a pretty cool interface. These charts you've been seeing are actually from HEMI2, and those 4 boxes are the control points. So these are Bezier curves. You can kind of see a little stepwise there on this one especially. But they're curves that do what I believe, and I've mentioned a little bit in class about how I feel that environmental phenomenon affects species distribution, and that it's logistic. Starts off having a slow impact, and then it increases rapidly, and then slows down again, tapers off. And so HEMI was created with Bezier curves to model these curves. And there's only 4 control points. In fact, we usually only use 3, and this was one of the big surprises in developing HEMI, is HEMI actually performed well against Maxent with a very low complexity, comparative complexity in the models. This one's been modified. I've pulled the curves out so you can see them. Normally they'd fit closer over the red area, but I wanted you to be able to see the control points. This was used by one of my graduate students, Melissa Kimball, in her thesis to show a couple of things. One is that because you can modify the control points, you can actually grab these points and move them or automatically fit them. She was able to show Doug Fir and a couple other species, she was able to modify the response curves beyond the range of the data that she had, and instead show it in other areas where we knew it existed but didn't have data for it. These are different Doug Fir responses for precipitation, temperature, in min and max. And here is a habitat suitability map from that. The one on the right is the range from the documentation. And then this is actually a noise injected percent difference running the models over and over again. And this was interesting. One of the things we found, which wasn't surprising after we realized what was going on, is that the high areas of uncertainty are around the edges of the model. In other words, pretty high certainty we feel pretty good about here, but around the edges is where we were struggling, where we probably need more data. As I mentioned once before in class, Melissa also found out that the stability of the Monte Carlo runs flattened out after about 100 runs, and it did this almost all the time. In fact, she invented these stability plots where we looked at the standard deviation of the performance measures, in this case AUC and AIC, and found that the cumulative standard deviation, so first of course it started off being fairly high because there weren't many values in the AUC, and then they flattened out pretty quickly. So we were feeling like we needed to reach stability before we could say we'd had enough Monte Carlo runs, and that was about 100. Here's the main sample that she modified the curves for. This is paper birch, which we have very little data for in its northern extreme environment. It goes way up into the north, and that was well documented, but we didn't have any occurrence points. On the left is the FIA plots for paper birch, and on the right is what she eventually determined based on other information and from the modified graphs. And here you can see where she modified the temperature range because it was known that paper birch was actually able to sustain much colder temperatures. We didn't have data in those high northern regions because there aren't a lot of people up there. Oh, and I should have said this one on the right is from the documentation, and then she modified the model in HEMI to get a more accurate model for the one on the left to match the one on the right. So range is what they tend to call it from the documentation anyway.